G'day again. So today we're going to look at the advanced cosine rule. So you're used to looking at cosine in your normal triangle, which is trigonometric, by saying, okay, if here's an angle, we want to find out what it is, and we know this length here is, say, 4, and that length there is 5. We can use a cosine rule to say cosine theta equals 4 over 5. Punch that in your calculator as shift cos 4 and 5 and get an answer. This is what we call an advanced cosine rule, so it's just a variation, but we're using cosine in a different manner. So we'll just wipe that out. And here we're going to find an angle based on all of this. So the rule is cos A equals b squared plus c squared minus a squared all over 2bc. And again, in triangles, when you've got your letters A, B, C, just remember they match, they're opposites. So here's an A, so there's an angle. Well then, over here must be the letter A. That's your side. And same for B and C. Now B and C in this case won't matter which side we put them on. We can put B there and C there, so that would be, that's your B and that's your angle C. But we don't really care about them in this side because we know those two are going to be our B and C, and it doesn't matter which order we use them in. So let's apply this formula to this triangle and see how we go. So we're going to get cos theta equals b squared plus c squared. Well, this is our A because they're opposite, so these are B and C. Doesn't matter which is which. So 11 squared plus 19 squared minus our A squared, 24 squared, all over 2 times 11 times 19. So what do we press here? We don't just press this in our calculator, we actually want shift cos. So you want to go shift cos on your calculator, or you can actually write just cos to the minus 1 because that's what's going to turn up when you press shift cos. So let's actually write that for a change. So cos to the minus 1 of 11 squared plus 19 squared minus 24 squared, 2 times 11 times 19. Press in your calculator, press the equals button, press your degrees, minutes and seconds button, and you end up with theta equals 102 degrees, 59 minutes and 45 and a bit seconds. So you could round that, and usually you do, to say to the nearest minute, so that's going to equal 102 degrees, and that would be 60 minutes. Well, what's 60 minutes? It's the next degree, isn't it? So if you round this up, this actually becomes 103 degrees. And you're done. G'day again. So we're going to do another one, same diagram, we've just moved theta to another place. We know that's 103 from the example we just did. Now what you could use, since you've done this, is you could use the sine rule, and you could say, well, this over this equals this over this on your sine rule, but we're going to use the cosine rule. So let's have a go at it again. So we're going to cos theta equals, now B and C have changed. So this is now B and C because they're surrounding the angle, and that one opposite there, that one's going to be your A. So we're going to get 11 squared plus 24 squared minus 19 squared. See, these two are opposites, so they're on the opposite side. This A is opposite, it's the furthest away. All over 2 multiplied by 11 by 24. Punch in our calculator, so we're going to press cos to the minus 1, 11 squared plus 24 squared minus 19 squared over 2 times 11 times 24. Press the equals button, press the degrees, minutes and seconds button, and we end up with theta equals 50 degrees, 28 minutes and 43.69 seconds. So that will round up to 50 degrees and 29 minutes. And you're done. G'day again, back for some more of the advanced cosine drill. So this time we're going to look at sides. Same formula, it's just been moved around, and you might want to do that as some practice. Start with the other formula and gradually work through algebraically to change it into this formula, because they're both actually the same formula, just moved around a little bit. So we're going to use it in this form, and we're going to find out what this A is. And again, they're opposite, so that's our A. Now I've used the same numbers as I've just used previously, so we can just about guess what this number is going to be. Let's do it using the formula. So we'll have A squared equals 11 squared plus 19 squared minus 2 times 11 times 19 multiplied by cos 103. And again, this B and C, doesn't matter which order I put those two in, still going to get the same answer. So we punch this in our calculator and we'll end up with A squared equaling 576. Just be careful that you don't just leave that as your answer, because often students do that. Big area, rushing in an exam, and you go, oh, 576, great, move on to the next one. Just read what you've just written. You've written A squared equals. So that, and there's no possible way that you can have 576 along that length when you've got an 11 and a 19. So just pay attention to the question and think, that's way too big for my answer. What's the answer? Well, obviously you've got to press the square root button on your calculator and you get 24 point and lots of zeros. So pretty close to 24 centimetres. Okay? We'll do another one in a second. G'day again, back for another one of the advanced cosine rule. So we're going to use the formula again. We're going to find A, and we're looking at the opposite. A is opposite its angle. So cosine of 20, and again B and C, doesn't matter. We can call that B, that's C, doesn't matter which way. So let's have a go and let's do this. So we're going to go A squared equals 24 squared plus 19 squared minus 2 times 19 times 24, just changing them around, multiplied by cos 20. Like I said, it doesn't matter which order you put B and C in. Okay, I've written B, then C, then C, then B. Doesn't matter, because you're plussing there, and this is one big multiplication. So then we get A squared, punch that in your calculator, and you end up with 80 and a few decimal places, but that's not the answer. There's no way it could be the answer, because you've got 24 and 19 and 80. There's no way that could be the length of 80. Impossible. So what have we got to do? Press the square root button. So A equals 8.9 centimetres. And you're done.